In this video, we see two objects being dropped simultaneously, a textbook and a piece of paper. Let's watch what happens. Well, the textbook clearly hits the ground first, but if we watch in slow motion and analyze the forces, we can see why that's the case. So we go back in time to just the instant at which the objects are dropped. The instant when the hand lets go of each object, we can analyze what the net force is acting on each. Well, we know that there's two forces acting on each of them, the weight of each of them and the air resistance on each. So let's draw in arrows to show the weight first. So I've drawn the arrow for the weight of the book much larger than the paper because the book weighs a lot more than the paper. Next, we have to draw in arrows to show the air resistance. Well, both objects are roughly the same size, and at the instant they're dropped, they're barely moving at all, which means they both encounter very, very little air resistance. We'll assume it's the same air resistance when they first start to fall, so we can draw an arrow in to show the air resistance that each feels. Now, because the weight of the book is so big compared to the force of the air, the net force acting on the book really hasn't changed very much than if it had been in a vacuum, when only the weight of the book would be acting. On the other hand, the paper has a very small weight to begin with, so even a very, very small force from the air is going to really decrease the net force acting on the paper, which will decrease the acceleration of the paper. This will result in a much smaller acceleration of the paper than if it had been in a vacuum, if there had been no air present. So if we watch in slow motion again, we can see that as the book falls, it accelerates, going faster and faster, whereas the paper moves very slowly at a fairly constant velocity. The book's already hit, and then the paper sort of drifts down and finally hits the ground.